Hello friends, today we are going to discuss uh, Unit 4 of a compiler design, that is runtime environment, heap management and introduction to trace based collection. Okay, let's start with Unit 4 of a compiler design. Here, what we are going to discuss? Runtime environment. In that, we will discuss the things related to the storage organization. In that, we discuss static versus dynamic storage allocation, static allocations of space, activation tree, activation record, calling sequence, variable length data on stack. In heap management, we are going to discuss the memory management, then memory hierarchy of computer, then locality in programs, reducing fragmentation, manual deallocation request, introduction to garbage collection, design goals for garbage collector, reachability, reference counting garbage collectors. Okay, then we will discuss introduction to trace based collection, a basic mark and sweep collector, basic abstraction, optimizing mark and sweep mark, and compact garbage collectors, copying collectors, comparing costs. Okay, let's start with unit 4 of a compiler design. Okay, first topic is runtime environment. Okay, compiler must cooperate with operating system and other system software to support implementation of different abstractions, that are name, scope, binding, data type, operators, procedures, parameters, flop control on the target machine. Yes, exactly. Okay, suppose we have the example, that is addition.c. So what we have to do, we have to compile and execute that program. Okay, but in the addition, what we have done, c is equal to a plus b, a is equal to 10 and b is equal to 20. So the compiler responsibility is that compiler has to provide the memory for a variable, b variable, and addition of both is saved in the c variable. Okay, so all this symbol table information, and this is the responsibility of compiler to must cooperate with operating system. What will be the result, what are the different variable, what is the binding. Okay, now next, the compiler does this by runtime environment, in which it assumes its target program are being executed. Okay, so what what is the responsibility by the compiler in runtime environment? It deal with layout and allocation of a storage. Yes, exactly, allocation is very important. Instead of allocation, what is to be going on over there? Access to variable and data, linkage between procedure. If procedure are available, then what we can say, that function declaration or procedure declaration, procedure call. Okay, and procedure definition which is to be provided, parameter passing, interface to the operating and input output devices. Next, how do we allocate the space for the generate target code and the data object of our source program? The places of data object that can be determined at the compile time will be allocated statically. Okay, but the places for the sum of data object will be allocated at the runtime. Okay, let's take the example related to the static allocation and dynamic allocation. Okay, so in C++, the static variable is available. Okay, in C++ we are already discussed the static variable. So what is the static variable? As its name suggests, that variable detail can't be changed. Okay, that's why it's called as static. But what is, and these things are compiled at the and allocated at the statically. But what about runtime or dynamic time? Okay, so that database or that detail which is to be upgraded during the runtime. Okay, heap allocation is the best example of memory management. We will discuss these things in upcoming lectures. The allocation and deallocation of the data object is managed by the runtime support packages. So what is the responsibility? Runtime support package is loaded together with the generated target code. The structure of the runtime support package depend on the semantic of the programming language. Okay, now start with storage organization. Compiler deal with the logical address spaces. Yes, compiler it deal with only logical address spaces. And the executing the target program run its own logical address space in which value has a location. The management or and the organization of this logical address space is shared between the compiler, OS and the target machine. Yes, exactly. OS map the logical address to physical address, which are usually spread throughout the memory. So what is this is the subdivision of a runtime memory. In that what we have: code, static, heap, free memory and stack. Okay, let's discuss this thing one by one. Memory, that is code. This is the memory location code which are determined at the compiler time. Memory location of code are determined which are compile time, usually placed in the low end of the memory. Next, static data. Location of static data at determined at the compiler time. Size of some program data are known at the compile time and which can be placed another statically determined area. Next, that is heap. This is the dynamic space area size changes during the program execution. And heap grows toward higher address, store the data allocate under program control stack. It grows toward the lower address and sorry heap heap grows toward higher address and is stored the data allocated under the program control. These are the things related to the heap. So as I already said that heap it is a dynamic memory allocation or the value of the variable which is to be changed during the what we can say that during the runtime. Okay, uh, malloc area in C is the example of heap. Okay, now stack it is a activate stack it is as its name suggests statically data which is to be provided by the compiler and which is to be compiled at the which is to be known at the compile time. And the best example is activation record which is allocated at the runtime. Okay, stack it is also the another kind of a dynamic memory allocation. Now next, free memory is also called as padding. Okay, now these are the few things which are related to the storage organization. In next lecture we will discuss activation tree. Okay, thank you.